Hello, my friends. So today I wanted to think through with you this new mechanism that I found that I think will be an interesting one. Um, I found it while I was working today in a coffee shop, and um, I excitedly decided to walk home to try and explore it here. So um, I'm adjusting to a new keyboard layout here. Let's see. Okay. Let me see if I can. Okay, never mind. Tried to fix some things and it didn't work. So, what we're going to be trying to do here is we're going to try to capture the notion. Hello. The what the hell is going on? Okay, we're going to try and capture this idea that has been plaguing me for a little bit, and we think that what it's going to look like. Okay, I really thought that this was going to scroll me in and out. Oh, God. Okay. What? I'm never going to get used to this. Why? Dark mode. What is edge scrolling? Oh, God. I don't want to go up and down, y'all. I want to zoom in and out. Oh, fuck. This is useless. I'm using a mouse. Okay. This is more what we're used to. I don't know. Too high up. We're just going to stick with this. Okay. You can be smaller. And onward. So, what we're playing with is we're going to throw a little icon here. It's kind of indicate somebody's willingness to change their mind. We have this notion of a pledge, and so that's going to go here. And let's left align all this, and then that means that this has some pledge. And this has some pledge. Okay. And so what we mean by this is we mean something along the lines of here's something that we think is true. Um, um, or something that we want to happen. So project A should be funded. And then here's an argument against it. Project A has problem XYZ. And our pledge up here, we're like tentatively calling this a curio. So this is like a expression of surprise, essentially. That if this was true, then a person would be willing to change their mind about this. And we want that curio to propagate through some relevance gate. So here's our relevance gate. And I mean, is there something that is so let me level you into how I'm thinking about this. Let's see, I need some space. This should probably be enough space. So the way I'm thinking about this is we're going to have some pledge amount up here. That pledge amount you can then stake with this pledge amount over here. So this is like the reuse leverage rule. These are just possible rules, things that we can play around with. So reuse or leverage would allow you to move this down here. This is going to have some attribute, which we have tentatively been calling the score. And for now, I'm just going to say that there's some score. It kind of hovers above this. And let's say that it has a score of 100 due to the stake. We then want to allow someone to pledge, maybe with reuse, and then get additional influence. So here we have like, we just have like a linear increase as you pledge. You can imagine that being instead of being 100 itself, this could be f of 100. Or let's call this well, it's fine, some function f of 100, which increases the score here. So we then have this curious. We have some relevance, and I guess this could be like C for curio. So let's see, what are we playing with that feels interesting? So the idea here is that this gives you these interesting dynamics where somebody is making statements about how they can change their mind, and as a function of making these statements, they're getting this additional influence, and so what they want to do more of this. And the first thing we might notice about this is that probably someone is going to cheat, and they're going to say something along the lines of, you know, let's go and grab something untrue here. Project A isn't being done on Earth. Okay, so this is untrue. There isn't a pledge associated with it. And yet, this person is saying they would change their mind if this was true, and they're getting this additional influence based on that. And so that's like trivially false. So let's call this like trivially false. And we get And so what we imagine would happen is somebody comes along. There's this other thing called a doubt. So we can just throw that over here. Let's call this ooh. Doubt. Oh, doubt. Okay. Great. And somebody else can now doubt them and reduce this impact. And so let's call this, let's say that they pledge 10. And so now this function that we came up with up here, where it is the pledge plus the function of curio, we can now, maybe we want to have two parameters that we're putting in here, and we have the doubt. I think previously I've called this also, this quantity, it's like the threat. I don't know if that's a good term. So, okay, so this is the doubt amount. This is the, I guess this is the curio. This is the thing that would change their mind. They're doing it through this. I'll note it like this. This is fine. And here's the threat. And it's a threat because at any point they could, it's because they get this additional influence in exchange for adding it. So here's the threat. Here's the doubt. This kind of like whole thing is the curio. I'm just naming things. The trick sometimes is you just give names to things, and it allows you to have a durable concept that you work with. And it's a little easier to give them kind of whimsical names than it is to just call it quantity A, quantity B, because like it gives you more to hold on to. So these names will change, but the the structure and the relationships, that's where all the meaning is anyway. So they probably will not. Okay, so we have this function, and then we have a whole bunch of options for how this function is composed. Basically, like what's the bonus influence? And let's say for now, it is threat minus, this is going to return, I'm just going to use Rust syntax, which, what am I going to use? No, it's fine. Threat minus, I think what will make sense is doubt to some exponent k. And then the whatever is larger, that or 0. So you can't get negative influence up here by like doubting. So I think that my bet is that that's the approach that we do. You could also do a couple of other things. You could do like k to the doubt if you thought that it should be exponential. And then of course you can do something like k times doubt. Hello? I don't think I think these are not going to make sense. I think this one will. Okay, so yeah, so this person is getting this additional influence up here. Okay, so we're about to need to introduce kind of a new set of concepts. Basically, I've just gotten you up to speed on how I've already been thinking about this. Oh, and we can do one that's trivially true. I think that would be good for us. By agents. Okay. Beings. Yeah, great. So that one's trivially true. And it doesn't matter what the pledge is here, right? In order to score this curio, we okay. So now by doubt, so what the next thing that we want to pay attention to is like if someone is doubting, how do they like why aren't they doubting everything, especially if we're giving them such a good deal on reducing the influence of project A, right? So they have this like bonus score for their curios up here, and it would seem like you could just pretty easily go in and doubt just a little bit on everything. So why would that be a concern? And so this is the conversion function. And on convert, you take in the threat and the doubt. Let's see. I think it has to be like I'm going to choose to do it on an aggregate level. I think doubting on a particular person's threat is not going to scale. It's just too much. You want to like take an aggregate of all of the pledges. Okay, so this is the sum of all threats. This is the sum of all doubts. In other words, like 75 could have come from one person, and 25 could have come from one more person or 10 more people. And then convert. So what we mean by convert, this is new. This is the part we're getting to the new stuff. The part that's new is that we're imagining when this person, we used to call this slashing. So when this person came along and slashed their pledge, we used to call these stakes. So when a person came along and slashed their stake, this person got slashed with them, right? So we could call this slash. And what slash looked like is something along the lines of so there's the size of the slash. I think like I've been calling that Q in my work. Let's call it S. So the size of the slash, so S over the total threat. So the percentage of the slash of the threat that you're slashing. Times the doubt plus S. So that's what we would have done before. And that was nice because it's a little clearer if we do it this way. Like S is going to be by far the largest Why would doubt ever get really big? Could doubt ever get bigger? Huh, I guess so, but such a waste. Uh, Probably people aren't going to do it. So, um, slashing is going to be um, it's going to be the total size of the slash s plus some amount of the doubt, and yeah, if we have a nonlinear, if we have a polynomial here, then that actually makes sense. That's actually worth it for somebody to do. Mm-hmm. That kind of makes sense. So, that actually makes sense for a person that is in favor of this to do. Well, does it? Okay, this brings us to the next question. How did this get out here? The next question, and into deeper new ideas. So first of all, let's call this. I was calling this slash. Now I'll introduce you to the new idea. The new idea is not just slash, where that money disappears, but we're going to call it convert. And we're going to try and turn this into a little bit of a market. I think we only need one more function for this. So by convert, we're saying that all of this becomes owned by this staker up here. So let's give these people colors. Blue people and red people. So the blue people, getting rid of this. It's done by beings. So the point of that second thing was just to show that this has nothing to do with the validity of this point. So I can get rid of that now. It's just bonus in order for increasing the surface area of your invalidation, because that's what science works off of. Okay, so we're introducing this idea of when somebody slashes, they're not actually totally slashing themselves; they're converting into ownership of this point down here. And when it comes to rules, this is another possible rule. We could call this convert captures or translates. And what this means is that so we have this doubter here. We're gonna have this convert action, which is called by this person. This person goes down to, let's say, 90. That means that it's 10 over. I'm sorry, 10 plus 10 over 100 times 10. And so there is 10 that's being converted into ownership down here. And then there is 10 that's being captured, or 1 that's being captured from the doubt. So this would become 9. And that results in a new pledge down here of 11, right? And by the way, if this is ours, let's pick a cute K for this. Here's a K of 2. So now that would be, there's a total, we're going from 90 minus, we started with and 10. So we started with 110. Threat, doubt. So that means that the curio was 100 minus 10 squared, which is 0. And now it's 90 minus 9 squared, which is 9. And so this has been profitable for the pledger to make this little bit of a slash, because now they have, it's cost them, they now have ownership of this. They think that it's true. And it has cost them 3. So let's compute the cost here. Actually, you can't compute the cost. That's a transition. What do we do? Well, you could add a dimension here. Oh, well, let's just do this. So we're going to have, there's going to be some net effect, and that means that please go back. There's going to be some net effect where the the curio gain is 9. The new ownership is let's call it ownership gain. Is 11. And now there's this notion of so at least right now, the way that I'm thinking about this is all owned by this person. And that's what I mean by convert. Just convert, capture, or translate. If it captures, then that one that was slashed here becomes owned by this person, blue. If it translates, then when they slash, they get 10 units of this, and this person gets 1 unit of this. I don't know how that game theory works out. So that's why it's one of the rules that we can play with. But then there's something that's missing here. And this is the new mechanism that I was playing with today. Basically, there's some market. I want to have some market price for these tokens. So you're getting 11 units of this currency here because we want to compute essentially a profit on convert. The conversion profit. / loss. And so this is going to be a conversion profit of, let's call it 3. And it would be 3 if, we have this assumption over here, which is that Yeah, the token value is going to be priced at 1. Okay. So with these assumptions, I'll do this. This, given these assumptions, this is our given bar. Given that token value is 1, conversion profit is 3. Okay, so in your head, you should have, like, this is one realization, but you should have like 2 rule dimensions that you can run off with. And one is that, is this reuse or leverage? So when they slash, did this become 90? And if so, then this conversion profit is going to change depending on the token value of source. So that's going to be source token value and then there's going to be token value destination. Okay. If we keep them both at 1, we don't even have to think about this, but they're not going to be at 1 for long. So that's the reuse slash leverage rule. If it was 100, then if it's not reuse, if it's not leverage, then this money is coming from elsewhere. And so, this could have been 150 because we're not bounded by this anymore. But that also means that it's money coming out of their pocket, which means that our concerns about plutocracy are higher. Wealthier people will have more influence. Okay, so then you have convert, captures, or translates, and if this is given the rule of this is captures. So given the captures rule, this is 3 because they got to take over one of the units here. And given the converts rule, this becomes 2, right? Because now this is 10, plus 1 in red. And then of course, there is doing both of them at once. And so that should start to describe a little bit of some of our design space. But that's not what I wanted to pay attention to yet. There's one final thing that we need. And this is what we're going to call the emission price. I was just having a conversation with someone about this on Warpcast. Who was I talking to? Where is he? Here it is. Ratchet. Okay. So the thing is that it might not be a price ratchet. So a ratchet seems to imply that it goes up all the time, which is true for most bonding curves. But we could actually have one that goes down for some reason. That's what we're going to play with here. So what was the other one? Vending curve. Or maybe like vending price. Um, but the somehow we have to emit a we have to emit a new token at some price, and that's what we want to play with. But we have this fun thing that we can do, and um, this is where things get interesting. The fun thing that we can do is we can use the value down here to reduce the let's call it the score or the price. What, like, it's clear we're going to have to change the name of this. It's not going to be called score anymore. It's going to be called there's a very tiny bug on here. Hello. There's going to be we need a new name for this because it's not merely the score anymore. It is taking into account, well, it's fine actually. We can have a score and then we can have some quantity that takes in score. So let's call this it could be a mission price. It could be price. I like the term vend. So this is gonna, for now, this is just gonna take in the score. Well, no, it's gonna take in the score minus the score of opponents. So minus the minus what? We have a bunch of counterpoint scores, and there's going to be some function that computes the credence of this point based off of the scores of all the other points. Yeah, I've been calling this credence. Credence. Volky likes to call this valor. Valor is a cool name. I'm feeling the urge to define vend in terms of score minus something, because even though like credence is going to take into account the whole graph, and so it's not quite right to it's not quite right but the credence isn't going to be isn't going to be larger than the score. So I think this is fine. We're going to call this the offset, and offset comes from big G, and offset is some transformation of credence. So let's say that credence of big G through some translation function is like isomorphic with offset, right? It's not like really important for our diagram here, but it's conceptually that's what's going on. Is we're running the credence algorithm or the valor algorithm or whatever the fuck we end up calling this algorithm, and it allocates a final number, credence, valor, to all of these various points. And here we're choosing to think of that through the through the lens of the score. So, and we're just doing this because we know that the vend is gonna be lower than whatever the score is. Is that true? Well, let's not get like too caught up on this. Somehow we're setting an emission price, and that emission price is taking into account the full graph, which includes the counterpoints here. So let's actually just call this counterpoints, because that's what we're interested in. And the counterpoints we're imagining to be objects that have these attributes associated with them. And so if you increase your, it's hard because I'm trying to think of this from, I'm cheating a little bit. I'm trying to think of this from both the perspective of the like the local perspective as well as the global perspective. And that is wrong. That is wrong. I should be thinking bottom up. So I should be thinking local only. Okay, so let's go back to this. And let's call this uh, we know that it's going to be something along the lines of the counterpoint score. Let's call it the sum symbol. I can't believe I don't have this in my little yeah. Sum. All right, let's fix this. Where does it normally come from? Go away. Do not need you. Oh, there it is. Okay. That was the last one I did. That was, I think, option. There it is. Option W. That makes sense, actually, because it's like a sideways W. Good choice. Okay, so we're going to do the sum of counterpoint scores. Each of them multiplied by this thing, which Volky has a new name for. He's calling this, instead of the relevance. Are you fucking kidding me? Go away. Nope, wrong one. I'm going to delete this app if it keeps doing this. All right, is that gone? he's now calling this the honor, which I think is fun. It's like because the idea is that playing with this notion that you can abuse like if you abuse relevance, you have no honor. Like you're fighting with things that shouldn't be fought with. So when people use like rhetoric, then you argue that it's dishonorable for them to use rhetoric instead of saying that it's irrelevant. That's kind of fun. Okay, so times counterpoint dot honor, right? And this counterpoint is a lookup from this. So this knows all of its counterpoints, and then when it computes the honor, it's just computing. It's the edge of this thing. And these are points, just like these are, but they have a special score name here so that we can tell them apart. And maybe they're normalized. Actually, what did I end up leaning towards for honor? Maybe I have it in decimals. Oops. I log in. Okay. What is going on? No, I don't think I saved it. If it's not there, then where am I going to find it? I wrote about it somewhere. Oh, I think I have a Jupyter notebook that I made for it. All right. Here it is. No, I don't care about identity. Okay, so these are the two that I came up with. What I'm calling source here, which must be score. So let's go ahead and call it score. Score. No, source. Starting endowment. Endowment I take to mean the stake, which we're now calling pledge. An important thing to get used to when exploring and researching something in a group is ontology flux. Like the terms you're using are going to change, and so you get to play a little bit of detective when you go back in time and figure out what did people mean by this in the moment. The reason that they change is because over time you're steadily like excising pieces of them. Um, and So a term that used to mean one big thing, eventually a piece gets cut off of it and it gets a new name. Um, and so um, let's see. And this isn't solved by like using variables, because it's this like the semantics come from the relationship between things. Eventually it will settle down. Eventually it will settle down. So, I think that this idea of a times min b over a 1, I think that produces something that looks okay. So let's just do x, or no, let's be y equals min a over x over x over y. And then, min of that and 1. Yep. So yeah, it's kind of sensible. And then the other one was what? Y. Okay, so um, this should be times y. Oh, shouldn't this be capped? Oh, this is just trying to say nothing below 0. What? No. Y equals, well, let's do x. So x is going to be strength of the source. Are we interested in source or relevance? Times r over x. We can just do this for now. What? And then it maxes out. This isn't helping me. Um, well, let's remind ourselves what we're trying to do. And actually, I haven't told you what we're trying to do. So that's hard for you to even know. What we're trying to do is we're trying to come up with some price for at which we would sell to someone a unit of this if they staked. So they stake something worth some denominated in dollars. So some dollar stake or pledge, and they get out the other side. Pledge. So emission. They get out the other side. Let's call it emit. And it takes some context. And that's what we're trying to figure out. But the important thing is that what else does emit take something else in? So here we have emit. It accepts the amount that you pledge. It's going to return the number of tokens of ownership that you get in this. So this now has this little tiny floating price associated with it, and it's moving around over time, right? And that's controlled by this emission function. And it takes in a pledge, and it takes in a well, it takes in this other thing called context. When you're a really lazy programmer, that's what you you can't figure out the right ontology. That's what you do. Is you just say like, well, maybe there's this thing called context, and we just pass it around. And what does context contain? Well, all the things that are necessary from the context. Oh. But fine. Context. Now what does it return? Well, it returns some price. So probably it takes in, there's some things that can be found on context. There's context.score, and there's context.counterpoints, and there's context dot TLDraw was really not designed for writing code. Context dot what else do you need? You need your counterpoints. You need the score of the existing point. And does it need to know the price? The existing global price? It better not. It's just saying, here's how many tokens that you can get for this many dollars. Yeah. Okay. So score. Mm-hmm. I think that's it. I think it just needs the score and the counterpoints. From that context. We already have an algorithm for this. And it works on a per tick thing. So it kind of the information propagates over multiple steps. And that's probably fine. But what I'm interested in, okay, so we have this, and we're going to call this the, we're going to call this, some, we're really not looking for real code here, I guess. Like one of the things we'd like to figure out is how this reduction function should work. Now that we know, this is counterpoints. Okay, we can simplify this. Yeah. Okay, cool. So I think let's count this as a checkpoint. I'm going to get some snacks and fill up on my water. And then when we come back, we'll be able to begin the conversation around how these dynamics might play out in an interesting way. And that, I think, should inform us of how the reduction function should work. That's what we're trying to figure out. Or that's probably like we're trying to move all these things at once. But obviously, the reduction function is the thing that we know the least about. And we don't even have to know how the reduction function works in order to get an idea of how, like, what constraints we've already imposed on how it can work and whether or not we like those constraints. So that's where we're going to be going next. Cool. This is fun. Be right back. All right. Got water. Got some almonds. I swear, almonds are like 43% of my productivity. I love almonds. They give you energy, but they don't, overwhelm you. You have 1 to 2 of them every couple of minutes. They're delicious. Okay. So, what do we need to think about? Well, it occurs to me that I haven't said what we're trying to do. So now that we're halfway through, why don't I let you in on the secret? Our goal is to build a new game for science, one that interacts seamlessly with money, and such that we yoke money and its behavior to the best of our scientific norms. And we're trying to evoke scientific behavior by giving people a first order incentive to make statements about how they could find out that they're wrong and to admit that they're wrong. And then to enable basically capital flight to occur across this massive network of competing ideas to the ones that are most that have the highest surface area for invalidation. They're the most precarious. They can be falsified, and yet nonetheless kind of survive that falsification process. So that's the game that we're trying to create. And, first order, it's really a simple idea, which is that you get some extra influence in order for in exchange for making statements about how you can find out that you're wrong. But it's hard when you start to try and figure out where you're going to get closure for this. Another way to say this is like, who's going to sponsor it? And your ideal solution, your optimal solution, is that it's self-sponsoring. That's what I mean by closure. And we haven't gotten there yet. But I think that something interesting is going to come out of this, this thing that we're looking at right here. So we have these 3 functions. They relate to one another in this interesting way. such that um, this um, this reduction function is constrained because depending on what makes sense for a selfish actor to do in this game um, means that this reduction function has to work in a particular way, and that's really useful for us because otherwise, it can be difficult to answer the question, how is this thing going to be principled? And recently we've been reaching for it's easy to reach for kind of like Bayesian ideas when writing this algorithm, the reduction algorithm. But there's potentially an argument that the Bayesian ideas are insufficient for the, I think for the same reasons that like Karl Popper would argue against Bayesian ideas, um, which is like, um, you know, to be honest, um, I don't want to like, to be honest, maybe I don't know what Karl Popper was really saying he criticized Bayesianism. So we won't go that route. Um, let's instead think about like the um, there's this recursive problem in decision making, which is that if you upregulate the probability of something occurring, then uh, certain things become more likely. And so, the as a result of doing them. And so there's this like recursive property. This is captured nicely in that famous saying that the easiest way to predict the future is to create it. If you're just an epistemic actor, you're at a complete disadvantage to the actors, the agentic actors that are out there like building and doing things. And um, uh, what that can mean is, this is fine maybe most of the time. Like it's great that doing has a systematic advantage. It becomes a problem when you start getting into, the outer limits of uh, of influence or power, where you're able to use the fact that you have most of the influence and power in order to retain most of the influence or power. And so um, uh, um, what that means is that you can't have like diversity gets squished when you're in those when you're on a landscape that has that sort of game. And so um, the question is, our question is, can you create landscapes that don't have that sort of game? And the answer is, I don't know yet, but maybe yes. Okay, let's keep going. um okay, the right next thing to think about is, is a dynamic that we think can reify the moves in this game. A dynamic that we think can reify the moves in this game. Let's see if it shows up. Okay. So, so we're going to assume, the context that we're going to assume is that these two are in zero-sum competition. I guess I can note that like so. They're going to have some relevance, which I'm going to ignore or honor. There's going to be a couple of different stories that we might want to tell. For now, where do we put this? Here's fine. For now, let's just tell one story. Working title is the name of this story. So what we want to happen is the event that we want to occur is that someone stakes. So there's a staking event. Where do we want to stake? We want to stake. By the way, staking event here. So we'll represent that with a, okay, so we're interested in blue. So that happens here. And we'll have a little runner along the bottom here, which gives us our names of the events. So here's a staking event. Boom. What should that then do? That should have some sort of effect on how do we, let's see here. Great. You go to the back. What do you want to be? Sure, fine. And that means that this should go down, right? Staking event occurs, and this should now go down. I think we're going to have a lot of events here, so I'll just go ahead and try and set us up ahead of time for the events. Okay, so that's what happens when somebody stakes. Because these are in zero-sum competition, the price here goes down. Then let's imagine, I'm going to make you smaller. Let's imagine what happens here is somebody read by. Okay, so that's kind of interesting. Already we have a kind of fun dynamic. So these are in zero-sum competition. As you buy this one is going down in price, down in emission price. So the strike price is lower. So this really is blue. Let's left align. Blue pledge. And you're going to be red pledge. Okay. So what should happen now is a red pledge maybe brings us up to here. Why is this like this? I guess it doesn't need to be like this. It can start at the beginning. Okay. And then when the red pledge happens, this needs to go down. So it went up pretty far. Let's just take it down here. Okay. And so these two, at this point should just be mirrors of one another. Ignore everything off to the right. We're just interested in the stuff to the left here. So these are mirrors because they're in zero sum and we're ignoring relevance for now. The next thing that can happen is somebody can, and they do this, by the way, either because they care about this outcome. So in Blue's case, they want this outcome to occur. In Red's case, either they want this to be believed or they want this outcome to not occur. And then what do we do? Well, the next thing that we can do is we can use our curios. So let's call it a blue curio. Okay. And of course, what happens here? Well, okay, but we're not paying attention. We're just looking at dynamics here. We're not looking at costs to players. So this blue curio occurs, and this is what must happen. Okay. Or I guess we call this a threat. Now we call this a red doubt. Okay, so, well, we should operate on the red. So here's the red doubting. If we're being like kind of rigorous about this, we would, hold on, please do not pause this. Okay, if we're being rigorous about this, we would well, it can't be negative, right? So we just know that it can't be above this line. So it can go up to here. So that's like the upper limit there. Oh no. Blue. Yeah, because the threat takes us from here to here. And then we can only undo it to some degree. So we can either go up to here or stay down here. Okay, so let's just do that. I don't know how important this actually is, but it will help me visualize. Okay. So either up to here or down here. So we can doubt like, no, don't die, don't die. I've had way too many looms die on me because my headphones died. I don't know why they would design it that way, but that is how it works. They must have fixed it. I don't know. I'm grateful that it didn't die. Okay, and so then, also somewhere between these lines for their doubt moment. By the way, the pledge distance. So if we wanted to also draw these kind of like support lines over here in blue, the maximum, and we're assuming and we are assuming leverage, then the maximum should actually only be here, which is kind of interesting. And if that's the maximum, then, well, let's go ahead and let's grab this and flip it like so and make it red. Huh, interesting. Yeah, so then it should be like so and like so. Right. So this would be assuming leverage. This isn't super important, but assuming leverage. Right, because what's happening here, what's happening here is that if we assume leverage, then this pledge here is being used in order to pull ourselves back up. And the maximum that we can pull ourselves up is this amount that we jumped here initially with our blue pledge. Assuming linearity of your score, which is what we assume here. Is that like the maximum that you can get is your threat. It would be nonlinear if this was like threat. It would be super linear. It'd still be linear. It'd be it wouldn't be conserved. So assuming conservation, which I think is fair. Like, okay, it could be a rule. Conservation of I don't know. I don't understand why you would ever want to have a threat that wasn't conserved. I think, you're already getting additional influence, and so the it's scaling with the number of things that you threaten. And so it would make absolutely no sense not to do it this way. Yeah, so let's just delete it. We don't need it. It's not a parameter that we're going to play with. Okay. So now red doubts some amount. Now what happens? Red doubts. This comes down. What other actions do we have? Now the only thing that can happen is blue converts. And so this relies on either does capture, convert, or translate. We might have a problem. Blue converts. Okay, so there's a problem here, which is that it might not be the case. We're going to introduce a new color here. Ugh. Okay. So here's the issue. Down here, when we modeled this out, we had project A is done on Mars as this point that like nobody there was 0 in here, if you remember. And now we're saying project A is being done on Mars is a point with some amount of stake right here. That was this move. They moved up here. So this is I guess this is a scenario where This is a scenario where red is the one that's doubting, right? Red both is doubting that they're going to slash and they're in favor of this. That's fine. That's an interesting scenario. And then we can do another one later on that has like 3 parties. Okay. Or has red not counter pledging on this point? And that won't be that hard to simulate. Okay, great. So now blue is going to convert. What happens when blue converts? This depends on whether we capture or translate. So blue comes down to blue converts. So they were here. They can convert up to the amount that they staked. So, or that they threatened. So this has to go down. Anywhere in here. And so the real problem is actually not. This is a this must be a score chart or a score or a vending chart. Like how much can you buy it for? Not what can't it be? It cannot be a ownership chart. So we should do an ownership chart next. Okay. So this comes down. Then what do we do? I know that this needs to be, but this isn't reflected. This isn't going to be perfectly reflected down here. So we're going to do this. We're going to do Command V. We're going to make it red. And the reason it's not perfectly reflected is because of this right here. So when you do this conversion, okay, so this is not affected by capture or translate. This is going to be, so how far did you go? From here to here. You're like slashing what looks like, let's call it half. And so this should actually take this up. Oh, no. Should do something like this. Huh. Oh, it has 2 effects. It should come down here. Oh my gosh. That's pretty interesting. Okay. Okay. Is there a way to get some oxygen in here? Maybe that will help. This is interesting. There's two effects that happen here when blue converts. Yeah. Okay. No, this is really cool. All right. Um, so there's so many noises happening now outside. Cars going by. Okay, this is cool. So blue goes down. Don't do 50%. 50% is always a mistake because you can lose information. So let's go down by. I think you actually see the effect the most if you go down by like 25%. Okay, so we were here. We're now down 25% from our original threat. So much we threatened. This goes down 25%, but then what happens over here? Oh, this is so interesting. Um, uh, we actually have to put 25% here because wait, I'm confused. That's red's doubt. Oh, yeah, this is a problem. We're conflating our action space with our score space. So there's these there are actions, and then there is score. This needs to be score. This middle thing needs to be actions. How are we going to do actions? So we just had solid boxes. Okay. It's close. Okay. And then don't need you. Come over here. It's really far apart. No. These are kind of far apart. Where's my... Okay, so the amount that blue pledges here is this much. I want it under, I think. The object will be blue. Okay. Then red pledges, and boy, red pledges a lot. So red pledges up to here, is that right? Yeah. That's annoying. Arrange bottom, line bottom. Heh, not line bottom. Oops. Now blue threatens. So blue, the size of blue's threat can be maximum this. We decided that it is... Oh, we decided they do the max. Okay. Why? Is that what we want? If I did 50% instead, we assume conservation. I think it's fine. Yeah. Yeah. If this was a simulation, I would change it, but like it's not worth redoing the chart just for that little change. Okay. Now red doubts. This is where we decide red doubts 25%. Oops. They doubt some amount. I'm going to make a perfect cube. That's pretty good. Is that what we had here? Hey, look at me. Yeah, pretty good. So now red doubts. Blue converts. Let's actually just make it the same here. So we're going to have to do... We'll have to look at the state space. And there will be information in there. But until then, I think this is pretty good because now we can think about this. So we know that um, uh, we know that according to our little equation here, S over threat times doubt is what you're going to take out, which is just 25%. So we know that this goes down by 25%. And then this goes, this gains um, that 25% plus 25% of this. So it should be gaining this plus, a little tiny bit here, like that. Just like so. So on first approximation, that is what is happening. But now the score is different. And um, the score of this counterpoint is different. And so the reduction function over here is going to return, when these two compete with one another, this is going to go further up and this is going to go further down. So we need a way to visualize these states. Actually, wait. This is okay. So I guess these are linear because we assume that the reduction function has some linearity to it. Blue threat, um, same thing, linearity. Red doubt, same thing, linearity. It's just like a red pledge. Blue converts. Why can't we just assume linearity? Because we've assumed it in all the other cases. um, it's not linearity. It's that there are two functions that are being applied. So all of these have one function being applied. This has two functions being applied. The first thing that happens is the conversion effect. The second thing that happens is um, uh, the effect of the curio, the curio effect. So let's do this. Let's make a new one. And now the curio effect we know is going to be something like threat minus doubt. So if the threat before was 4, and now we have 1 to the k, let's not do that. Let's do 8 minus 2 to the, what do we say it is, 2? That's what we have before. And now what we have after is we've converted 25% of this. So we have 6. And then we've converted 25% of this. So 3.75 is the curio effect. So what was it? 8 minus 4? So 0.025. So it's fairly small. If this was 2, it's like this little thing here. But I'm going to exaggerate it for visibility reasons. And then I'm going to terminate you right here. It's fine. So this is just representing that there are now 2 updates that happen here. One goes from here to here. Second one goes from here to here. And we'll continue on with our second line. How do you delete a? Oh, it's probably shift. Shift? No. Knowing this tool, you probably can't do it. I think we could do this. Okay. Cute. Great. Lovely. And so what we should be seeing out of this is that there's this conversion that's happening, and like one way to think about it is a by the way, when I slashed, oh crap. Oh, interesting. So this might be an argument against leverage. It's at least an interesting question. So if there was leverage, then there would be a third effect, and the third effect would push this even higher because um, this would have. Mm-mm. It wouldn't. Well, would it push this higher? It would push this lower um, if there was a third effect here. So assuming leverage. Hmm. I don't think it changes this one. Medium blue dotted. Okay. Yeah. And then how do we want to finish this? Because we got this extra something here, but we've used up all the interesting moves. So we've had a pledge. We've had a pledge, but the other team had a blue threat, red doubt, a blue conversion. Hmm. Maybe there is more. But either way, you can see that converting is like this. It's really helpful to Project A. I'm sorry, Project A. It's really helpful to the Mars one. To point, let's call it point B. This would be point A. This is point B. So, yeah, it's highly helpful to point B because it. Okay. So I think we're getting close to the closure. Hmm. Because the next thing that we need is market price. So what's fun about this is um, emission offers a floor for emission price offers a floor or ceiling. Ceiling for market price, right? Why would you ever buy on the market for $10 per token? Why would you ever pledge on the market for $10 per token when you could when you could buy? No, why would you ever buy on the market for $10 per token when you could pledge? Mm-hmm. Um, when you could pledge for $9 per token. So it offers a ceiling, potentially on both of these. Hmm. Interesting. Hmm. Oh. Okay. Okay. How do we use a ceiling? We have a maximum price. So the ceiling, let's say these are the ceilings. The no, these are the market prices. Let's move them down. If these are the market prices and they're down here, oopsies, let's do this. So if the market prices are below these um, vending prices, then there's no effect. This is just the game that plays out. Hmm. Um, by the way, these market prices don't have to move together. They could be, oops, they could be different. But I'm just trying to think through. Um, well, the first thing to recognize is that we must be imagining that this is the vend price and that it's being linearly modified with as a result of score, which means that it's being linearly modified as a result of counterpoints, which is fine. It's totally fine. But I actually didn't know what this curve was. I thought this was score before, but it's even further downstream than that. This is the vend price, which is why we can put market on here. And now we're putting a maximum. Now we're putting a maximum price. So let's just imagine that this was the story, and for whatever reason, the market price was stable throughout this period. Then this move here, or blue pledged, doesn't actually make very much sense for blue. They could have pledged about half that much and then bought the rest on the market. Am I thinking about this right? Um, 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 so I want more of these tokens. I sell. I stake. I stake. What is going on? Oh boy, I'm running out of steam here. Okay. Um, we get we have a market price here. We have two options as a participant in this game. If the market price goes higher than the vending price, we prefer to vend. So somebody will pledge, and they'll pledge up to the market price. If market price is below this the vending curve, then is there any reason to vend? No, no selfish reason. You might pledge because you want to influence the outcome. What's the point of doing that? Oh, because you care about the outcome. Okay. You care about the outcome. And the market price is oh, it's a signal to you as to whether or not you're way off base. Like whether or not you disagree significantly with the rest of the world. That makes sense. hmm And it might matter when you slash. Might matter when you slash. Let me stand up for a second. Oh, wow, this is great. Standing desks. Thank you. Um, okay, this makes sense. It's feedback from the market as to whether or not you are off base with your. Yeah. Where is that market demand coming from? So the one of the reasons that I'm doing this is because I have some sense that one day in the future, index wallets and negation game type mechanisms are going to be able to become friends. And of course, that could be a source of a market price. Um, if there's not demand for this token, uh, then you'll have no effects. There's not demand for this token. There are no effects. No market effects, just staking effects, which is fine. In fact, that's what we would hope for. Oh, cool. Huh. What happens when okay, so what happens when you slash? You slash and uh how is it deciding the rate at which you get to translate into the new one? Is that done with a market price? Hmm. Okay. All right. One sec. I'll be right back. Okay. Um, onward. I have my warm jacket on now because it's summer in San Francisco. Okay. So, hmm. The question that I was asking is whether conversion is a thing, whether conversion rates are a thing, and they're not. Not really. What they would do. So, if you were to use this in an index wallet environment, um, then instead of this blue pledge being a complete donation, it's a donation where you get a token in return. And that token in an index wallet economy could have market value. But um, depending on whether your local community also values it. Um, Interesting. What's really interesting is that this is an emission scheme, um, which I wasn't really planning on doing with index wallets. I was planning on having a fixed supply. Um, so now you hook this up to an emission scheme, and maybe you get interesting behaviors. Hmm. Um, hmm. Yeah, because you could imagine people saying they really like something, and then they get a whole bunch of the token, um, and it increases the um, demand from wait, yeah, and it causes the rest of their community to increase their valuations, um, which reduces the total cost of the donation in the first place. Mm-hmm. Huh, that's cool. Um, and what's nice as well is that this conversion here, it's just moving the currency into a new account. Yeah, so that's nice. Hmm. Hmm. Yeah. So the currency gets moved into a new account, and all right, let's just finish this off here and here. Cool. 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 Um, this is a cool little chart. Let's make a thumbnail out of it. Let's do the whole page. Here, we need like we need good standing up hair. This is it. This is it. Great. Um, I think we're pretty much there. We've got changes to the vending price, which is related to a market. Once we hit market, then that's kind of our markup boundary, right? Our markup blanket. That's the point at which we, as long as we know how we interact with that, then we can ignore it. We now have our, we know how these 2 points relate to one another. We can see that we can see how conversion works. We can see how we can imagine how honor would work here, relevance, like it would just kind of attenuate the total effect of these 2 on one another, especially up here, right? This would be less strong. We can see why blue would convert, because they plan on, because they get essentially a profit for doing so. They're being bribed by red to convert. There's always an incentive to find concilians. That's cool. We know why the red that's playing down here would doubt, because they worry. Why they would be worried about doubting, because this person might slash and that could be expensive for them. Yeah, I guess actually that answers the question whether we capture or translate. We must. Well, if you capture, then there's a cost. Capture, then cost. Because if you don't capture, if you translate, then there's a cost if they don't agree with B. So if red doesn't like B, there's not a cost. It's like free if red likes B, has an affinity for B, because they basically got nonlinear influence temporarily. So I think it should be, I'm leaning towards capture. As for leverage or reuse, it is genuinely hard to tell. Seems like without leverage, I don't think that how this behaves gives us any information on leverage or no leverage. I think that, which is good news, actually. It just sort of means that you're going to have, if you include leverage, then the changes that you see are going to be more exaggerated. So we should use other criteria to figure out whether or not we permit leverage. Okay, that's great. We didn't come up with an equation for honor, but the way it would work would be this reduction function must be something along the lines of, I mean, it will be like, let's see if I remember my sum of What did I like from over here? Of why would you need a min? Isn't this identical to maxing? Isn't this just I don't think that makes sense. No, I don't know what the reduction function is yet. And how it incorporates this. I mean, oh, right. It was the honors counterpoints. Okay. So you recurse here, but we could call this. I actually kind of like cs.honor horror honor, which is after. Which is I like the idea that and then love that. And then honor is going to be something like that's what this was. Uh, I don't know how to do this yet, but somehow we're attenuating signals that shouldn't matter here, and that's essentially what reduction is doing for us. And we're like gonna hide that behind this. So we've made it one level deeper, like kind of ignoring the fact that uh, honor is a type of score, which is unfortunate. And honor must be between, it must be between 0 and 1. Let's just give it a type signature. So it's going to be a real that's in symbol. Uh, so we don't know how this works yet, but I've got a little signature. No, that's a weird place to recurse because this is something that's defined. Oh, maybe that's fine. Sure, that's fine because this doesn't call these. Okay, cool. I think that that's um, uh, you'll have to forgive the bad syntax here, but you get the idea. Sum up all of that. I think that's pretty good. Hmm. When we don't, this tells us what we know that we don't know, which is how do you compute honor. Now, right now, we're just assuming it's a one, and we get all these interesting dynamics that come out of it. So there's something that's still missing here. I don't think we've reached. We don't have closure yet. Why? Oh, we should save. I love this. That is amazing. Uh, that's amazing. Okay. Um, okay. We don't need to assume anything. Well, it is pretty weird to say that um, you would be willing to change your mind if this is true, if it's not relevant, right? So it must be competing in some way. But that's in conflict with something. It's in conflict with something. What is in conflict with? Um, hmm. Fuck. Hmm. Well, um, I mean, a bunch of ideas are springing to mind. One of them is kind of fun. It's this idea that maybe there's no such thing as staking on the honor, staking the relevance of something. There's uh, only these curios, only these statements that you would change your mind if this was true. It's a fun idea because right now there are three moves to learn. One, staking here, staking on points, which includes this one and this one, staking on relevance, and then staking on how you could change your mind. So, let's see, stake a point, relevance, and because we don't have another name for it, the curio. And the cases that can occur is that let's just talk about point A. You're in favor of point A. You're in favor of point B. You are you think that they are relevant. But if you don't have a dog in the fight, why do we care what you think? If you don't have a dog in the fight, why do we care what you think? We're going to call this pledge. No, we're not. We're going to call this. You want to pledge a point. You want to pledge relevance. You want to pledge the curio. So, well, if you believe A, then you'll pledge the curio on B. If you believe B, you'll pledge the curio on oh on um, This isn't helping me. Maybe I try and fill it out anyway. So let's just call this the curio of A, and then this is the curio of B. And this is going to be A. This is going to be B. And so obviously if you believe A, then you're going to pledge against A. If you believe B, you're going to pledge against B. If you believe that it's relevant, I don't know. Do you care? It depends. It depends if it helps you. But so that's actually a good observation all by itself. If you believe in A, you could pledge this, and if you believe in B, you could pledge this. Okay. In fact, there's really never a reason. Well, there's this case which is like there's like the object. So let's pick the object. Can you? Let's do this. So this is going to be the object point. So if this is the object point and you believe it, then if you believe this and this is the object point, okay, this is not meaningful. Well, yeah, this isn't really meaningful. No, you're not going to do that. Oh, right. Because you don't want anything to be able to attack you. Mm-hmm. That makes a lot of sense. Wow. So that would push you in the direction of saying the only reason that A, somebody who believes A, where A is the object, would ever stake on the relevance is because of a curio. Is because of the benefit that they get from making a statement about how they can find out that they're wrong. B, meanwhile, that B doesn't really care itself about succeeding. It's a supplementary or it's a sub argument. So it doesn't care. In fact, it wants higher relevance because it wants to be able to attack A. And so that's the asymmetry that we're exploiting. And so we can almost infer the relevance thanks to the fact that there's this mutual willingness to be invalidated of B saying A could make me wrong and A saying B could make me wrong. And the believers in B could then say, no, A does not affect us. Like, let's say these are both object level. by object level, I imagine that this is like a funding decision, And so this is like, do we fund thing A? Do we fund project A? This is like, no, because X is true. And so like people care about, um, there will be a class of people who care much more about this than they care about the arguments, the sub arguments. And so that's most of what's going to be fought over. If these are both, do we fund project A or project B? Well, now, um, it's interesting. It almost seems to make the argument that relevance should only apply when you have this double opt-in. So your mutual invalidation, you can't see anything here. This should have another arrow. So this mutual invalidation here that exists here to here, that should only exist, I guess. Like one possibility would be, can I please select? Okay, would be if this was true. So both of them are actively, so this might be also inverted. So maybe this is like 10 and maybe they're counter pledging. The blue people are counter pledging here. And then you infer the relevance based on those dual moves. That stops a lot of regression right there. And then I don't have to figure out how this works. Huh. It's like you have this double opt-in. Does that mean that the bonus is accrued? No. So you should get the Curiel bonus independent of whether or not it's considered relevant. Then it entices the other person to. That's interesting. Okay. Whenever there's like a whole new what the okay. Let's go and explore it. So, under what conditions would you do this? Under what condition would you prefer to stake once again, you have three moves. Well, as a believer in, so in this case, this would be X. Let's go. Let's just duplicate this. As a believer in, this is like the full matrix, but okay, so you have these options. You can, well, I mean, what do you have? What moves can you make? You can stake here. You can stake here. Oh, and you can doubt. Okay. Now, in what situations do you do these moves? Ugh. Hmm. Oh, thinking is so much work. It's crazy. Crazy how exhausting this is. Because like one day in the future, I'm going to come back to this and I'm gonna be like, wow, that was so like fluid, and but right now it just feels like pain. And obvious, right? Of course, like far enough in the future, you look back on your old work and you're like, okay, that was obvious, but like said in the most stupid way possible. Okay. Um, we should do that just so that it's clear. What goes on the vertical axis here? It's so an interesting question is why would you ever stake this? Hmm. Why do you even need to stake? Wow, how productive of a day would it be to go from four moves that you can make down to just two? That would be a productive day. Like it's these little curios all the way down. Mm, so why would you ever stake against point point A? Well, you would do it if you prefer it, and you don't think any of the things that attack it would change your mind. Okay, so maybe this is more of a maybe we just write this. So prefer, but no invalidation, falsification opportunities. Okay, so that's thing one. The curio you would stake if um, why wouldn't you just uh, why wouldn't you if it's purely linear, why wouldn't you just stake more? Yeah. So okay. So already believe staked A. So this is why it must be. This gives us an answer here to this rule. This needs to be. Oops. This needs to be yes. And I think, well, and then you doubt if you think the other player. You want the other player to slash, or don't think they will. Yep. Huh. Interesting. Hmm. This is dope. If we want to be cheeky, we could come up with an equation here, just so that we have it, and it would basically be min of of let's call it yeah. Oh, over. Interesting. Wow. Huh. This is cool. Um, okay, let's think this through. So your f of a and your f of b is getting um, so intuitively, like the choice I'm trying to make right now is should this be max or should this be sum? And if you make it sum, then um, it sets off an arms race where each team is trying to kind of like um, pledge more in order to get more influence thanks to their curio as it's added to their score. But then that's increasing the relevance. So um, then on the other hand, if you make it max, wait, some you're increasing the base. Well, let's just plot them. So it's going to be y is what do we want the dependent to be? Let's increase. So let's do min of a comma b, a comma x over sum sum. Okay. Starting at oh well, let's just do a plus x. Okay, that's fine. And meanwhile, this is going to be over. Okay. So this is oh well, this is interesting, huh? Well, let's fix some things. First of all, you can't have an a. So a is the upper one, and you can't have a stake less than 0. Oh wait, hold on. Can you? No, you can't. We fix it. So all you can do is you can kind of move this point out, and what? That's y equals x. Where is G coming from? This should be offering me a slider. That's really weird. I just wanted this so I could. And max G should be. I guess max G should be 1. And let's make it black. Please. How do I make it black? Interesting. Why did I think that this was a sensible thing to choose? Huh. All right, give me a sec. Okay. Took an hour break. Got some food in me. I'm so excited about all the progress made today. Let's see. Oh, is there somebody knocking at my... Okay, someone was knocking at the door. Where we left off an hour and a half ago for me, 3 seconds for you, was we were trying to model this right here. And we were trying to answer the question, does the structure, can we infer this quantity that we were calling honor from just the these two properties? You know, we're calling them threat and doubt of the counterpoints. And so it makes sense. First of all, let's just think through, why does it make sense to take f of A and f of B? So f of A is just the curio of that counterpoint. Our lambda is just unpacking that. And so we take that curio and we say that which is, if we need a reminder, which is the threat, this thing right here, minus the doubt to some factor. It's polynomial. And it's either, and if doubt is too big, then it just returns 0. So curios can't be negative. They're a bonus. They're a bonus that you get for making statements about how you could be wrong. And then in here, we're saying something like, A and B. So then we're saying whatever's the smaller of the two, in this case, 10. Oh, no, it's not 10. Well, let's just compute them. Why not? So it's going to be 10 is the threat minus 2 to the 2 is going to be 6. So we have 6 for A. And then B is going to be 90 minus 9 squared. That's going to be 9. And so whatever is the smaller of the two, 6, do that divided by, and this is where I feel like we have the choice of either divided by whatever is the average of the two. I'm sorry, whatever is the, oh yeah, we got three opportunities. So another possibility is, I wonder if this works. AVG? No. So we have like a panoply of curves to choose from. If we can do divided by the uh, uh, divided by the sum, max, or average. I think what makes sense to me is, well, I think at red we can rule out because the activation never gets up to 1. If we go blue, it's nonlinear. So it's much more kind of activated on average. And if we go green, it's actually really weird. Then it linearly rises until it reaches 0.76. Oh, that's A. Oh, interesting. So the more you stake, the longer it takes. Mm-hmm. And what is this? Like if the other person overstakes, yeah, that doesn't make sense. So if A puts in 2, where's 2? Here's 2. And B puts in 2.5, they can pull it down. Oh, and they can get bonus influence from the curio. Something about this feels wrong. No. What do you use as the base here? So what I'm struggling with is this. What goes down here? Do we want it to be able to reach 1? It's interesting though when you start playing with how people might fight back. So let's like model it out. So instead of merely a and x, we're actually going to write so this is going to be threat t, I guess. D Desmos function. Yeah. So I guess this is the curio. Come on, go over. And we're going to have some threat. What's our equation? Max t minus d. Max t minus d to the k. And okay, we're going to just set this to 2 for now. Oh, and comma 0. And now honor h is going to take in there's structs. Okay. So we'll have A be a list of A sub 1 and, oh no, A sub threat and A sub doubt. So those are moves made by the A player. Is that what we want? Do we want a list? Do we want to just do A sub doubt? Oh. Okay. Undo until we get back to this. And then I think we can do A sub threat, A sub doubt. Okay. We know that these can only be positive. And for now, let's increment only by 1 because. And then B sub. How do we duplicate? Can we duplicate this, please? This will be B, and this will be B sub D. 0, 1, 0, 1. Do we threaten or do we doubt? Oh, this is 1. And this. Okay. Beautiful. Okay. Everybody starts at 0. And now, what do we want to plot? I guess we'll just plot honor right now. So let's add a note. Let's save this. So min A sub min of C, A sub T, A sub, oopsies, A sub T, A sub D, C, A sub T, B, B sub T, B sub D, and great. Great, it doesn't work. Why doesn't it work? Fuck. Oh. Great. Just because it was at 0. So the threat is here. Yeah, you can feel that. That's interesting. Okay, so now instead of B sub D, we're going to do X. X. Interesting. So when it's at 0. Okay. This is interesting. What's going on? Oh, shit. Oh, wait, hold on. This should be X. This should be A sub D. Okay. Okay. Yeah, okay, so this moves it. I'm threatening you more and more and more. And if you would like to maximize influence, just put it out here. Oh, that's so cool. Okay. The way to read this is this is cool. The way to read this is What the fuck is this telling us? It says that the amount of doubt, not that B must doubt, the believer in B must doubt, is 1.732. Oh, that's kind of fun. So you can play this game of chicken, right? Whoa. Oh, I see. You can play this game of chicken where I'm going to threaten you more and more. And if I can threaten you onto the backside here, then I force you to need to doubt me in order to remax this. Okay, that's kind of fun. And then I'm like, threat, doubt. Okay, so that's honor. How do we level that up into? So then, I mean, in principle, we can take this all the way to the top, right? I'm way too tired to do that. This has been a long day. Um, but I mean, this makes sense. Um, like the dynamics here are interesting um, and should be explored more. The algorithm probably isn't perfect, but finally we've reduced it down to an atomic unit. There's no infinite regress as we run off to relevance land in order to try and figure out how to compute the relevance here. Like we just do it based on this, and you can even imagine a a counterpoint being made in here somewhere against this, and like yes, it could affect the honor, but it would be like it's its own atomic thing. And then the only thing that we have to worry about is the order in which you compute that. Um, so that is pretty cool. And then you would require. There's a couple other things to pay attention to. That you don't have cycles. This would have to be a cycle-free graph, but or it would just have to be. It should be the case that cycles are expensive in some way. But as long as you do that, look, can you see this plant? It's like got pink leaves. It's beautiful, pink and green. But that is pretty interesting. And this idea of totally getting rid of relevance as a move, wow, it's amazing. I guess you still can. You can stake if you want. And it would just be the score of the relevance plus whatever the inferred honor is. But nonetheless, useful distinction. The way it interacts with markets is totally sensible. The story of when you do what also makes sense, especially as you start to think about this game, where like you're you're baiting someone into doubting. Pretty fun. Pretty fun. Uh, can't believe that we've answered both of these questions. So we've answered the leverage question to the positive. We need leverage. Otherwise, you could just do everything with staking. And there's no point in having the epistemic leverage, the curio. You can do everything with, and then you need captures. So this one is what we choose. Because if you don't have captures, then there's no cost to conversion. And so there's nothing sharp about it. I'm actually not certain that we have do we have closure? Let's see. Do we have closure? What I've got to thinking about is the way that the entity that uses this manages their does their effectively their currency management. I think it's a little bit beyond what we need to answer right now, but like the a point could say something like mint X amount of new currency and send it to so and so, or sell X amount of currency in exchange for, something else. So basically, it can make monetary moves, and those monetary moves then, you know, you play the game in order to dispute. Um, One interesting thing is that we're only playing this with 2 points, but in a real game, you would have many points, and then basically the aperture of the honor will determine how much information flows. And you do allow the score to go negative in as you run the computation. Oh, hmm, hmm. No, this might have implications where you don't want to let it go, because if people are buying, you could just, well, like the question that I'm asking is how do you map score to the emission if the resultant score, oh no, this is different, this is different. um, yeah, that's different. Curio does not take, okay, great. Emission takes in reduction though, which right now reduction can go negative. So I think that's a That's a problem. Um, that is a problem. The reason that we allowed negative in the other one is because we wanted polarization. I should just show you what I'm talking about. So, so as we run this forward over several iterations, we can consider this to be like the score, and it's just applying a really simple algorithm. And if we, so I'm gonna like reset. We run this forward, and you can see that like there's this experience where it goes, like it starts going down, and then it starts going up again. So this still ends up being green, but if this was just a couple more, let's see at what point does it turn. There's going to be a point where it flips. Oh, this aperture might not be open enough. Let's see, there it is. Okay, so somewhere around here. Oh, look, it's neutral. And then, yeah. So point is just to show that, and then you can start to have long distance effects. Which begin to be interesting. So the point is just to show that the way we're thinking about it right now, you can have these. Why is the emission taking into account the reduction? Okay, if we didn't have that same property, we would have to figure out a order in which to run the algorithm. Oh, if we have an order in which we run the algorithm, or it could just be local information. It doesn't have to propagate up. The propagation could come from people changing their moves. Okay. Well, that's kind of like what Volky would say. Okay. This makes sense. Hmm. And it's surprising. So you know that you've made it to the end of like a good work day when um, you are exhausted. Um, you found something that feels promising, and it's not what you expected. This is an interesting structure. Huh. Okay. So anything else for me to do while I have my while I have context? Because here's the thing: I sleep on it, and tomorrow I have no idea what I did. Let's lay out um, what the next step would be. It would be um, well, I think it is to start. Obviously, it's to start thinking through the um, uh, the incentives of the players. Um, how would you start to model this? How would you find out that you're wrong here? Okay, what would be our curio? So we'll know we have failed if um, if um, um, call them bad faith and insincere are similar. Like the biggest risk is that if you play this game, you can develop a reputation for converting that scares off everybody always. And so you don't actually end up with sensible conclusions because people with good reputations are running around kind of bullying you. But why can't you play that game back? Let's see. Um, what else could happen? I mean, we've answered this question. So, like, why do you need these three things? You'll stake. I mean, yeah. So you could do like population dynamics, like estimating the the benefit of a conclusion. So that's something. I mean, that really would be kind of the way to show that this works. Is you have a bunch of private benefits. Then you have a bunch of signals that you send, and ideally you would do it in the context of some. It's not merely preference, but it's in the context of some discovery process. So you have to have fog of war. Mm-hmm. Hmm. they start to be. I mean, I don't know if we're yet at the point where the the mechanism is concrete enough that the moral arguments begin to matter, but I'm lining up some of the uh, at least two that will come up is um, one is that you're paying people to um, I guess it's the same thing. Like what you're doing here essentially is your threat is actually you in part paying people. Um, oh no, a doubt is you paying someone to change their mind. Um, and um, various people are going to have various different concerns with that um, for different reasons. On the one hand, some people will say, you know, if the disadvantaged party is the party paying, then they'll say, well, isn't it unfair that they should have to pay given that they're disadvantaged? On the other side of the story, um, when you have the powerful person who's paying, you'll say, isn't it unfair that the person who's paying has all of this power to pay? Um, and maybe there's a third reason, which is that doesn't this distort people's mind-changing behaviors? Um, and these are good arguments. Um, but I think that one of the properties that we want, hold on. That is a loud fire truck. One of the properties that we want is so much noise. I don't know if it's loud for you. It's really loud for me. One of the properties that we want is that holding a particular position kind of becomes precarious, so that it's a sincere signal of your preferring it. And so uh, that seems like a compelling. We want that property. That's a good property. Um, so that's great. I think that this um, is making some amount of sense. I mean, it's definitely concrete. And it would definitely have dynamics if you played this game. Um, I'm not doing some. We're going to do max. So you know what you could do if you wanted long distance information is you could randomly pick each of these. You could set some grain and then randomly shuffle through the board, randomly select points, and then have the points have their effects. And then and the grain would be like the size of the effect. It would control the size of the effect that was applied. And so that would kind of allow information from all over to affect all over. Poor Loom keeps asking me if I'm still here. Well, it's probably time to get going. That's good. Really, really good. Beautiful. Beautiful work was done here. What's amazing when you're done and you look at what you've accomplished um, is how little information is actually here. Like most of what we discovered is what we cut out, and most of the value of this is what we did not consider. And it's amazing how expensive it is to produce uh, a little a crystal, something as crystalline and pure as this is. Um, yeah, I don't want to stop. It's like I feel like now that I've got it all loaded in my head, I might as well just keep thinking about it. Um, that conversion profit is going to be interesting. So I think that's something to pay attention to. Is stop. It's fucking worst app. Um, you think it's going to be a useful app, and then like the voice is really annoying. It can't read most pages. It just like sort of bounces around. Um, it uh, interrupts you all over the place. Like it's always has this massive thing on the side, and then it puts this little play button everywhere. Like I'll use it when I want to use it. I don't want you don't need to make my browsing experience bad. And then it overrides all your shortcuts, um, so that randomly it'll just start shouting at you. Not a good experience. And like, why aren't the speaking models better yet? AI is amazing, and you're still using these like terrible text to voice robotic models. It's horrible. Okay. Um, the thing I was going to say is that, well, yeah. So the game theory around what's the conversion profit, what's the benefit of the outcome, because one way that you need to think about this is as so Cosine bargaining is this it's basically this argument that says you can pay people to change their minds in economics. So if you have a neighbor who's like pounding on the wall, and you don't like that they pound on the wall, then you could say, um, and let's say they're doing it as part of their job, like they're uh, they teach an exercise class. There's probably some price at which they would say, okay, I'll stop pounding on the wall, or okay, I'll do this, in at midday instead of at midnight. Um, and uh, this is kind of so you can think of doubt a little bit as that sort of process. Is like, at what point will they change their mind? And the ratchet is useful to achieve uh, basically to facilitate a negotiation process, so that, and the fact that the point is executed, um, or the proposal is executed autonomously, um, means that there's no holdout problem. Um, uh, all you Harburger taxation fans are thinking the same thing I am. So, um, yeah, I think that there's a there's a way to think about that as well. Like you're offering some reward to certain people. Hmm. What if what if honor was times max of A and B as the numerator? What would you do then? What do you put as the denominator? You can do sum again. Oh, this would be kind of interesting. Um, so let me just see if I can. So let's do max, and then let's do yeah, that's interesting. So oh wait, what? Oh, that's funny. When doubt goes too high, it moves that structure backwards, flattens it out. When so that doesn't really make sense. Hmm. No, I mean you could. Okay, fine. Let's try one more thing. Oh, I guess that kind of makes sense. Right. Okay. All right. I'm done now. Super productive. Thanks for watching this. What is wrong with you? If you actually saw this part, then put a little two, a little peace symbol in the comments. You get big props from me if you've done that. Okay, bye.